everyone. Today we are going to discuss the hydrides of group 16. Okay, today we are going to discuss the hydrides of group 16. Okay, their properties. Okay, today we are going to discuss preparation, structure, and their properties. Okay, so one by one, let us discuss all the things about the hydrides of group 16. Okay, you know, all the hydrides of group 16, they form hydrides. General formula is H2E. And what is E here? Oxygen, sulfur, selenium, tellurium, and polonium. That is, it is H2O, H2S, H2SE, H2TE, H2TU. Okay, so these are the hydrides of group 16. So let us discuss their preparation. Now, you know, hydrides of sulfur, selenium, and tellurium, they are prepared by the action of acids on metal sulfides or metal selenides or metal tellurides. See, if there we have like FeS, so this is metal sulfide, iron sulfide. Where iron sulfide is used? Well known instrument, you know, Kipps apparatus. For what we are using this Kipps apparatus is used to produce? Yes, beta, tell me. Kipps apparatus is used for what? Can you tell me? Kipps apparatus is used for anyone? It is used, they are well known, it is used for the generation of H2S in the lab. It is used in the generation of H2S in the lab by the action of dilute sulfuric acid on iron sulfide, that is FeS. So dilute sulfuric acid means it is H plus ions, right? So H2SO4 in dilute H2SO4, it give H plus ion obviously. So you can write it as H3O plus, H3O plus, because it is dilute H2SO4. So we get Fe 2 plus ions along with H2S gas and H2O liquid. Okay, so in this way we produce H2S gas. So metal sulfides or metal selenides or metal tellurides, when they are treated with the dilute acids, we get their hydrides. Okay, so these are the methods of preparation for the hydrides of group 16. Now come to the structural part. Now in structure, so H2E. Okay, now in group 16 elements, valence electrons are can you tell me how many electrons are there? Because its general electronic configuration is NSO, NP4, NSO, NP4. Am I right? So 2 electrons are used in bonding, so remaining are 4. So there are in H2E, there are 2 bond pairs and 2 lone pairs. total number of pairs surrounding the element central atom are, yes, are 4, and the arrangement is tetrahedral. Arrangement is tetrahedral, and hybridization of the element is sp3. So when these are arranged, there are 2 lone pairs and 2 bond pairs. Okay. Now you know lone pair repulsion is greater than lone pair bond pair repulsion, which in turn greater than bond pair repulsion. That's why bond angle is less than tetrahedral. You know, otherwise it is 128 minute. But when we say in water, in case of water, you know, oxygen is surrounded by and 2 lone pairs. Okay. So lone pair repel each other, lone pair repel bond pairs, and that's why bond angle decreases. So in water, bond angle is 104.5 degree, and its shape is, we can say, bent or V shaped or angular, because of the 2 bond pairs. Okay, and lone pair repel the bond pairs, so angle is less than tetrahedral and shape is called bent, V shaped or angular. Okay. Now come to next part, that when we go from oxygen to sulfur to selenium, tellurium, as we go down the group, size of the central atom increases. Okay, as size increases, so what happened? Electronegativity decreases, and that's why what happened to position of bond in H2E? Position of bond pair shifts away from the central atom. As we move away from the central atom. Okay, that's why means from the central atom means as we move from H2O to H2E. Okay, and therefore repulsion between the bond pairs decreases, and that's why bond angle, as repulsion between bond pairs decreases, so bond angle decreases. Okay, and you know in H2O bond angle is 104.5 degree, in H2S it comes to 92.1 degree. In H2SA it is 91 degree, and in H2T it is 90 degree. Okay, so this is all about bond angle. Saad, Charitra, is it okay? बोलो बेटा. Hello everyone. Is it okay? Is it going smooth? नेक्स्ट टाइम से बोर्ड पे पढ़ा सकते हैं, है ना, पर आज के लिए बोलो। क्या साउंड में प्रॉब्लम हो रही है क्या कोई? Okay, so it is all about bond angle. Now, next is volatility. Okay, thank you. Volatility. You know, all the hydrides of group 16, they are volatile. All the hydrides of group 14, sorry, group 16 are volatile, and their volatility increases. First, it increases, okay. Volatile nature increases from H2O to H2S, okay. First, it increases and then decreases from H2S Ansh, thank you so much. Your donations really boost my morale actually. It's not like that you are paying me without any reason, but it really boosts my morale because you are my means say Lishansh Luthra was in DPS with me. Currently he is in Australia, and donating money as and when it is means he wants to donate. Thank you, beta. Okay, so now it means boiling point. Now, what about boiling point? As you know, volatility increases from H2O to H2S and then decreases. That means boiling point first decreases. Can you first it decreases and then increases? The point of H2O is 373 Kelvin. Okay, but in H2S, boiling point comes down to 213 Kelvin. Okay, and then it goes on increasing. Can you tell me the reason why there is abnormality in the boiling point? Say here like that, or in yes, beta. What is the reason? So see, the abnormal high boiling point of H2O is due to abnormally high boiling point of H2O is due to strong intermolecular molecules are associated through hydrogen bonding. Okay, molecules are associated through hydrogen bonding. Okay, but all other elements of group 16, and why they are associated through hydrogen bonding? Because oxygen is more electronegative, but all other elements, they have much lower electronegativity, and because of much lower electronegativity, they do not undergo hydrogen bonding. This is the main reason why water has do not undergo hydrogen bonding. Strong intermolecular hydrogen bonding. Now next part is from to even polonium, size is increasing, and that's why molecular mass increases, means H2O to H2S, size increases, molecular mass increases, and because that is wonder about the attractions. Okay, wonder about attraction. Increase. And when boiling point increases, showing abnormal behavior due to strong intermolecular hydrogen. Rest of them shows normal behavior. Okay, that's why if you say the overall in volatility, so it is H2S, then H2SC, then H2P, and last is H2O. I don't know, I am not able to see your messages, that it is not displayed on the screen. Oh, this is all about trend in volatility. Okay, and if we see the boiling point order, then boiling point of H2O is maximum, and then it is H2AA, H2SC, and H2S. So H2 is least volatile, and if we draw it pictorially versus molecular mass, then water is at the upper end, then this is H2O, H2S, then it goes on increasing, H2SC, H2, this is the trend. Good evening, Harshil. Okay, now next is we see that bonding. Okay, then volatility, boiling point. Now थोड़ा दे दिया हमने। हम्म, हम्म, बहुत ज्यादा प्रॉब्लम हो रही है। ए यार, क्या कर सकते हैं? कुछ नहीं, वेट बेटा। ओ थैंक यू। और एक मिनट ना। आई थिंक नाउ इट्स ओके। हाँ अब बेटा अब नोट करो बोला, अब बताओ। यस। नहीं नहीं, एक मिनट ट्रायल तो कर ले पूरा। अब बोलो। अब वीडियो क्वालिटी बोलो, सॉरी ऑडियो क्वालिटी बोलो अब। मैं थोड़ी देर पढ़ाता हूँ, देन लेट मी नो। ओके, तो सी, let us discuss the acidic character. So you know, hydrides of group 16 are H2P. They are weak, Dipole means a dibasic. Dibasic. Okay. They are diprotic dibasic acids. Dibasic acids. Okay, and thus they dissociate aqueous solution in two stages. See, first H2E dissociate in aqueous solution to give solution. So they give CO plus along with He negative and He negative further dissociate to give one more right. So the acidic increases down the group from H2O, then H2S, H2SE, H2E. So when we go down the group, from H2O to H2TE, their acidic strength increases. Their acidic strength increases. H2O is weakest, then H2S, then H2S. H2T. Why is it so? It is because it is explained on the basis of hydrogen element bond dissociation energy. Okay, bond dissociation energy. You know, as we go from HO bond, then HS, HSE, then HE. You know, size of atom increases, bond length increases. When bond length increases, bond strength increases. Okay, it means tendency to release hydrogen as a proton increases, and that's why H2O is least acidic, while even H we can write and H2PO is most लैग हो रहा है अभी भी है. पूरा कर लेते हैं आज. अब क्या कर सकते हैं, एडजस्ट कर लो थोड़ा. आई एम सॉरी फॉर दैट, पर मेरा मैं करूँ क्या, का कसूर है, ये नेटवर्क का कसूर है. हाँ चलो ओहो ज़्यादा प्रॉब्लम हो रही है ना, सुनाई भी नहीं दे रहा है. तो थर्मल स्टेबिलिटी भी डिक्रीज करेगी एज वी मूव फ्रॉम H2O to H2T, आ जाएगा एंड ब्रेक्स ऑन हीटिंग। क्या करेगा? reducing character increases। द रीजन ये थर्मल स्टेबिलिटी क्या करती है? डिक्रीज, इसलिए रिड्यूसिंग करेक्टर करता है ओके फ्रॉम H2O to H2T। दैट्स ऑल फॉर द डे यार, चलो यहीं रखते हैं ना। सॉरी फॉर डिस्टर्बेंस, बट क्या कर सकते हैं, है ना। ठीक है, मैं अब ट्राई करता हूँ फिक्स करने की, है ना। ओके, बाय बाय देन बेटा। ठीक है, रखो मैं।